This is a monocrystalline silicon-based solar cell. I always wonder how this piece of thing converts sunlight into electricity. And that is what we are going to discuss in this video. There are different types of solar cells in the market. Solar cells made from silicon, germanium, cadmium telluride, gallium arsenide. But silicon-based solar cells are the industry favorite because of its affordability and availability. This video is sponsored by my friends at Udemy. Udemy has excellent online courses on solar power technologies. You can learn about solar technologies and set up your own solar power plant by doing this course by Leandro Caruso. Link is in the description. He is really amazing and the course is superb. Give it a try. You won't regret it. Silicon in its pure form, in its intrinsic form, does not conduct electricity. Why? Take a look at silicon structure. A silicon atom has 4 valence electrons. These 4 valence electrons perfectly bond with other 4 silicon atoms and form a diamond-like crystal lattice structure. So there are no free electrons in the valence band. That's why silicon in its pure form does not conduct electricity. But we can make silicon a semiconductor by adding external elements called impurities into the pure structure of silicon. This process of adding external elements called impurities into the pure structure of silicon is known as doping. There are 2 types of doping, N-type doping and P-type doping. Suppose we are doping with phosphorus. Phosphorus has 5 valence electrons. 4 of these 5 valence electrons will form bond with other 4 silicon atoms and there will be an extra electron. These free electrons are the majority charge carriers in this type of semiconductor. Since electrons have negative charge, we call this type of semiconductor we created N-type semiconductors. Suppose we are doping with boron. Boron has 3 valence electrons. These 3 electrons will form bond with other 3 silicon atoms, then there will be a lack of electron in a bond. This lack of electron is called a hole. Holes are the majority charge carriers in this type of semiconductor. Since electrons have a negative charge, holes can be given a positive charge. So this type of semiconductor we created by doping with boron can be named as P-type, P for positive, P-type semiconductors. A solar cell is a junction of P-type and N-type semiconductors. So take a look at what happens when we form a P-N junction. In the N-type region there are free electrons and in the P-type region there are holes. So definitely the electrons will diffuse from N-type region to the P-type region and combine with holes. This diffusion of electrons from the N-type region to the P-type region will leave behind positive ions of phosphorus in the N-type region and will cause negative ions of boron in the P side. This charge separation will build an electric field from N side to the P side. This diffusion of electrons from the N-type region to the P-type region continues until the electric field becomes sufficient to block the further diffusion of electrons from the N-type region to the P-type region. And there is an equilibrium upon which there is no diffusion of electrons. At this point, there is a region around the junction where charged ions of impurities are present. This region is called depletion region, and this P-N junction is the basics of semiconductor electronics and a solar cell. Our solar cell is ready. Now is the time to understand what happens when it is exposed to sunlight. Sunlight is a stream of photons. Photons are the very basic unit of nature. They are also known as energy packets. When photons fall on the P-N junction, loosely bound electrons will absorb the energy and move from valence band to the conduction band, which leads to an electron-hole pair. I feel a little tired, so I feel more comfortable sitting here, right? So, if I drink a cup of coffee or something, I feel more energized and tend to stand up and move around. And that is exactly what happens when the energy packets or the photons falls on the electrons. The electrons will absorb the energy and move from the valence band and conduction band. Valence band and conduction band are energy levels of electrons. But because of electric field present in the depletion region, electrons will be pushed to the N side and holes to the P side. If we connect the N-type region and the P-type region through an external circuit, the electrons from the N-type region will flow through the external circuit and reaches the P-type region combined with the holes by creating an electric flow through the circuit. This is how a solar cell works. Hope you have clearly understood the physics behind solar cells. If you have any doubts, put it in the comment section. Thanks for watching.